In this demonstration, we're going to look at how to use Air Magnet Survey Solution or Air Magnet Survey Professional in order to design a basic wireless network. So what we're going to do is say we want to create a new project. We'll call it test. And we can choose different project types: GPS projects, non-GPS projects, Cisco Prime infrastructure, survey or planner. We're just focused on non-GPS at this point, so we'll accept that default and click Next. And it wants us to import a floor plan right away in this tool. So we'll click the ellipsis and select our Executive Office Suite floor plan. Notice we can import JPEGs, bitmaps, and again, DWF, DXF, like most of these tools can do. Click on Open. And we're going to say we'll set the dimensions later by using the calibration tool. So we'll click on Next. And we'll overwrite the file because it already exists. Actually, we'll save it with a different name. And click OK. Now, we need to choose the type of environment, much like most of these tools. So it can be a restricted closed office, which is what we're going to say. It can be an open space with cubicles, commercial warehouse, outdoor environments of different sorts. We can set the default AP power if we wanted to right here, and we can set signal propagation assessment for how many feet out we're going to do that. And like most tools, if you press F1, you can get help with what these options would do as far as your deployment or your design. We'll click on Next and we can enter descriptive text. We'll just click Finish in this case. And so that brings in the floor plan, but it's saying, you know what, you didn't calibrate it. Do you want to do it now? So it's really kind of forcing you to do that important first step, and we'll say yes. And we'll recalibrate site dimensions after measuring. So we'll say yes. And then you simply come up and click at the end of your tack in this tool, which is kind of confusing because you don't know whether to use the top end of the triangle ruler or if you want to use the tack, but it is the tack. And we'll click this dimension that we know to be 10 feet. Click it and say it's actually 10 feet, and then recalibrate. And that'll set our width and length dimensions automatically for us. Now remember, this calibration is very, very important because if you don't do it, you're going to end up with propagation from your APs that are incorrect. So to illustrate that in this tool, we're going to go to Planner and we're going to place an AP. We'll just put it somewhere here on the map. And now what I'm going to do is refresh my visualization, and you can see the propagation there. But if I go into my measuring tool again and recalibrate, and I say, you know what, instead of this being 10 feet, this is actually 40 feet, and click recalibrate, and then refresh, you can see a very different propagation pattern, even without walls and so forth. So always make sure your calibration is correct. I'm going to go ahead and delete this AP off of the map and recalibrate it appropriately. Okay, so now that we've recalibrated, we can refresh. There's no AP, so that'll just go away. We can go ahead and design our coverage area. So I'm going to say I want to create an arbitrary coverage area. And that allows me to just click the corners of my coverage area and build the area that I'm actually interested in having coverage in. And this is useful if I want to do the project planner and have it recommend to me where it's going to place APs. Then I can go ahead and do my walls. If I click the wall button, I can choose the kind of wall that I want. So I might want to put a brick wall all the way around the outside here to indicate that we indeed have those brick walls. Even though we may not be that concerned about interior propagation, remember, materials have reflection patterns as well, which does change the coverage pattern. So I've got my brick wall, and then I can do drywall around the inside where I want. So I might indicate there's a drywall that runs along right inside this brick wall all the way around. And normally you would take a little more time, you would zoom in, you would certainly be more accurate than what I'm worried about in this case. I'm simply wanting you to get a feel for what these different design tools offer, and in this case, Air Magnet Survey Pro. So I've done that. Now I'll go ahead and draw a couple of straight walls here. Just so we have some walls in place to see how it does impact our propagation. And how it impacts the recommendation of the planning tools when it comes to actually choosing where to place APs and so forth. Okay, and we'll say that's good enough, and we'll worry about drawing all the walls so we can see the difference in impact. For example, right now, if I place an AP down here in this area, and then I refresh my propagations, you can see exactly what that heat map looks like now. So clearly, these walls are affecting the propagation of RF energy. We can see the dry walls causing some attenuation. We can see the brick walls causing significant attenuation here at the greater distances. So let's go ahead and delete that AP and refresh again. And now what we can do is we can use in this case, the planner, the planner advisor, in order to have it place some APs. And this gives us some criteria. And so what we can do is say we want to do both 2.4 and 5 gigahertz. We can indicate the power transmission level that we want. So maybe we want to use 10 milliwatts with 2.4 and 20 milliwatts with 5 gigahertz. We can enable 802.11n support if we want to. Just know that by default, that's going to use 40 megahertz channels in even 2.4 gigahertz. So you'll want to make some adjustments to the properties there in this tool if you want it to only use 20 megahertz channels instead of 40 and 2.4 gigahertz, as well as in 5 gigahertz. And set your antenna height for how high the ceilings are. Make sure you get that right. And then go ahead and click on OK. And it's going to go through the process of thinking it through and planning where it's going to place your APs. In this case, it recommended only placing one AP. That's because this is a pretty small office space, and I didn't really set any type of capacity requirements that would demand more APs than that. But now what I can do is I can go in just for sake of demonstration, and I can recalibrate again. And let's make this space bigger, just so we can see what it thinks about it when it's much larger. So we'll go up to 40 feet again instead of 10. So we're making it 4 times bigger than it actually is. And then we will refresh once again. And now we can see we're not getting the coverage we want. So let's go ahead and do the planner again and say OK. And now you can see it's having to think a bit more. It's a bigger space. It's trying different locations. It's letting me know where it's trying these locations. And then it's going to make the recommendation. So now we see the APs that it has placed. I'm not at all happy with the placement of these APs. We've got one AP right up here on the brick wall, so that's not a good location. So we would want to move these APs around, possibly even deleting some APs or adding more APs. But you can see that the planner tool here gives me a starting set of APs that I can actually work with. And you can see then the heat map generated from them. Now we can also go to the display view, and here we can really just focus in on different heat maps if we want to. So we're looking at signal strength. We might want to look at channel interference and see what kind of problems we might have with interference there. And this gives us an interference severity level. We might want to look at predictive phi data rates. And we might want to look at throughput. These are all things that we can simply evaluate from different heat maps within the tool. So you can see this tool in comparison to the others that we're looking at. We're looking at a total of 4 tools in 4 different videos: Tamograph, Air Magnet Survey Professional, Echo Site Survey, and IB Wave Wi-Fi, and all restricting them to this basic floor plan and what they look like there for the most part. So this is one tool you can use to design a wireless LAN.